Okay, ready for part 2 of this. So I identified all the prime and composite numbers up here. Now we're going to list the factors of these numbers. Sorry, like I said earlier, I think it's best to just start with number 1 and move up from there. So we know 1 times 24 will work. Then we just consider 2. Yes, 2 does go into 24. 2 times 12 is 24. Then you think about 3. By the way, one trick to figuring out if the number 3 works, if you just add these two numbers together, 2 plus 4, that's 6. Since 6 is divisible by 3, so is this number. So 3 times 8 gives you 24. Then we do 4. Yes, 4 does go into 24, 4 times 6. Okay, 5 does not go in there. And 6 does, but we've already covered 6. So like I said, if you just start from 1 and go up, once you hit a number you've already done, you know you're finished. So those four are those four pair are show all the factors of 24. So we'll follow the same process with 40. 1 times 40. Then we think 2. 40 is even, so 2 works. 2 times 20. Okay, 3 does not go into 40. If you did 4 plus 0, you get 4. 4 is not divisible by 3, so neither is 40. But 4 will go into 40. 4 times 10. 5 also goes into 40. 5 times 8. Okay, 6 will not work. One trick for 6. If both 2 and 3 go into a number, then so will 6. Because since 2 times 3 is 6, 2 and 3 have to both go in there. So that's why they won't go into 40, but they will go into 24. 2 and 3 both go in 24, so that means 6 has to as well. 7 doesn't go in for 40. 8 does, but we've already done 8, so we're covered. So I'd like you guys to take a second and pause this. Just give you about 60 seconds to try to fill out these two, list their factors. So go ahead and pause it, please. Okay, so we'll do 1 times 100, 2 times 50, 3 won't go into 100, but 4 will. 4 times 25, 5 goes into 100, 5 times 20, 6 does not go, because hey, 2 and 3 don't, so 6 can't. 7 won't, 8 won't, 9 won't, but 10 will. And since it's 10 and 10, I know that's as far as it will go. Because I've gone down to 10, it's okay to use it in the same one, but once I see a number over here, I know nothing higher than that will work over here. So anything higher than 10, we've already used up this line. 60 is a bunch of them, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Some people think this is why they chose 60 minutes in an hour, because it has so many factors for a relatively small number. 7 won't work, 8 won't work, 9 won't work, 10 does work, but we've already used it. All right, time to share some coloring. Sorry, no homework passed this coloring, it's our notes. So using your divisity rules to help color, let's do composite numbers, and we'll just leave them blank because there's most of them. And hopefully a lot of you have blue. If you just want to circle it, you don't have to color it in. But if you have a different color, just label it correctly here. So we'll say blank or white for composite. We'll say blue for prime, and I'll just say red for neither. So again, I'd like you guys to pause and try to figure out what each of them are. And once you get through at least half the list, you can go ahead and press play again. right, here it comes. So they do give you a hint that there are 25 prime numbers from 1 through 100. So if you look carefully, there's 25 blues. They did color 1 as a red because 1's neither prime nor composite. Because remember, 1 is the loneliest number. It's neither. But you can see in the first line, 2, 5, and 7 are prime. In the second line, 11, 13, 17, and 19. In the third line, 23 and 29. In the fourth line, 31 and 37. In the fifth line, 41, 43, 47. Next is 53 and 59. 61 and 67. 71 and 73. 79 and 80, 71, 73, and 79. 83 and 89. And then 97. So this is good to keep in handy if you just forget what the prime numbers are. You don't have to remember any that are 3 digits. I mean, there certainly are some that are 3 and 4 and 5 digits, but it's really just the 2 digits you'll need to try to become familiar with. Okay, last page. Prime factorization. I think you have done this before. I've heard you guys talk about doing it maybe in 6th grade or maybe in elementary school or both, but the goal is to break this down into its prime factors. Now, there is more than one way to get to the final answer, but there should always be the same final answer no matter what. And I'll show you an example on these. It'll show we'll take 2 different routes with 24, but still get the same prime factorization. Because if you remember from the first page, we've actually got 4 choices of how we could, really just 3, because you never want to use 1 in the number. That doesn't help or get anywhere. So we could do any of these 3 in order to begin our prime factorization. So we're just trying to break this down into its pieces that are prime numbers. So I'll just do 3 and 8 to start with. And this works because what we're saying is 3 times 8 is 24. Now, since 3 is prime, I can stop that side of it. I don't need to go any farther. That's already a prime number. So I'm going to circle it just so I know I'm done there. Okay, 8 can be separated into 2 and 4. 2 is a prime number, so I'm going to circle it because I don't need to take that any farther. 4 is composite. It's 2 times 2. And those are prime, so we'll stop there. So the prime factorization is 2 times 2 times 2 times 3. And it's normal to put the numbers least to greatest. Or, using exponents we learned yesterday, we could say 2 cubed times 3. And let me show you how if we choose a different starting point, we'll still get the same end. So just like 3 times 8 gives you 24, so does 4 times 6. Now neither of those are prime, so both of them need to keep going. 4 becomes 2 and 2, because 2 times 2 is 4. Now those are both prime, so I can circle them and stop there. 6 is 2 and 3. Those are also both prime, so I can stop there. So you can see they come up with an identical result. 3 2's and 1 3. So 2 times 2 times 2 times 3, or we could say 2 cubed times 3. Okay, we can do the same thing with 100. Like you saw on the first page, there's several ways we could start with 100. Don't use the 1 in 100, that's worthless, but any of the other 4 would be fine. So I'll just do one most far apart first, 2 and 50. 2's prime, I stop there. And even here I have more than one option, because I could say 2 and 25 for 50, Or I could say 5 and 10. It's not that one way is right and one way is wrong. As long as the two numbers you pick multiply to be 50, you're good to go. So I'll just do 2 and 25, but if you do 5 and 10, that's okay. I'll circle the 2 because it's prime. 25 is 5 times 5, and both of those are prime. Sorry, the sheet worked out weird here. So we get, let's write it right here, 2 times 2 times 5 times 5, which I can also write as 2 squared times 5 squared. Okay, now I'll do the ones that are closest together, 10 and 10. 10 can be split up into 2 and 5. Those are both prime. And hey, 10 also, the same thing can be split up into 2 and 5. So we end up, as we should, with identical results. 2 times 2 times 5, or 2 squared times 5 squared. Okay, if there's time, pause and you try the 4 on the bottom, then I'll show you the answers. If there's not time, then you can just go ahead and start working on the homework. Stop the video now. I haven't forgotten you. I'll show the answers in just a moment. Okay, now you can take a second and pause if you need to see my answer. Now you may, just like I pointed out up on the top half of the sheet, you may have not had the same route I took when you did 240. Maybe you chose to start with 2 and 120. That's completely fine. But it is important that what you get at the bottom is identical to what I get. You should have 4 2s, 1 3, and 1 5. Sorry, I'm not showing the right thing. Hold on. Where are we? There we go. Sorry, 240. So again, if you don't have an identical tree to me up here, that's okay. You could have had like 2 and 120 to start with. But what is important is you get the same result as me at the end. You should have 4 2s, 1 3, 1 5. Okay, with 96, again, doesn't matter if you have an identical spread up here, as long as your end result is the same. You should have 5 2s and 1 3. Okay, 700. I ended up with 2 2s, 2 5s, and 1 7. So 2 squared times 5 squared times 7. So you should have 2 2s, 2 5s, and a 7. And for 600, I ended up with 1 2 3 2s, 1 3, and 2 5s. So that's 3 2s, 1 3, and 2 5s. Okay, you can work on the homework from here. Good luck.